Hello students. So once again, as per my promise, welcome back to the Miso study video classes, and in this particular video, as it is mentioned in this heading, that is, we are going to discuss mutual inductance. Actually, in one of my previous videos, I explained you the concept of self inductance, and then I promised at that particular point of time that these two things I will discuss separately. So here it is a new video, that is mutual inductance. Now I need a diagram, fine. So I will draw the diagram, then I will explain you how you can correlate your this mutual inductance with the previous concept of self inductance. So I think I should use 2 to 3 colors chalks. So this is one coil, okay. Let us say it is primary coil, and in this coil this is the source, fine. This diagram you all are aware, we discussed it, fine. Now there is another coil close to this coil and in this coil a galvanometer is connected, no source but a galvanometer. Basically we want to analyze the effect of this onto this, okay. That is why we are connecting this galvanometer. So first I would like to mention something about this diagram. There are two coils, fine. Let us say it is secondary, primary and secondary, and this is K, this is K, this is E, okay. Now first listen, then I will write down. Press the key, circuit is complete, current flow will start, fine. So magnetic field, and magnetic field intensity will keep on increasing as the current amount will keep on increasing, similar to that previous video, fine. So flux change will take place, but the problem is this flux change will do something very interesting with this secondary coil. This secondary coil will feel itself something without any motivation. It is like that, my neighbor is eating lot of aloo paratha and I am gaining lot of weight without any reason, something like that, fine. So in P coil, P and S are just symbolic representation, primary, secondary. In P coil, as is pressed, okay. In P coil as K, that is key, is pressed, so current flow will start and flux, magnetic field will keep on enhancing, so flux will keep on changing, start, and magnetic field, thus flux will start changing. I am not saying increasing, decreasing, our concern is only changing or not changing, fine. Let us use this paragraph for some new explanations. Now because of this flux change, in primary coil EMF will come into picture, induced current will come into picture, and also with this primary coil self inductance L is associated, fine. So in totality I can say due to these changes, fine, no problem, few things are changing, due to these changes, fine, due to these changes EMF will appear in P coil. And this EMF ultimately, basically by means of induced current, will start opposing any change in the flux in this primary coil. So, till now whatever is I am explaining, whatever is happening, it is happening with the primary coil. Still I not started telling anything about the secondary coil. Fine. Then what we can say, because of these changes, a flux building process will also start in secondary coil. Fine. Because of these changes, a flux building will start in S coil also. Now, this story I explained. Whatever now I am going to do is, I am going to take the help of this diagram. Fine. So, after writing this much, let me allow to once again come back close to this diagram, because now I want to tell you something. See what is happening on. Just listen. Key pressed, current flow started, flux change will take place because of the change in intensity of magnetic field. Accordingly, EMF will come into picture, induced current will come into picture. So, it will start opposing the increment in the current flowing process in this primary coil. Fine. Because of the flux change in secondary coil also, a flux building process, EMF building process basically associated with the flux change is also starts taking place. So, ultimately now the use of galvanometer is clear to us. Galvanometer will start showing some deflection. Fine. This is the first scenario. So, that I mentioned over here in S coil also, and in galvanometer deflection will take place. So, what we can say, without connecting secondary coil to any source, anything, nothing is touching from the primary coil to the secondary coil, but in secondary coil some deflections will start appearing. Okay. Now, this entire story is taking place when the key is pressed. Okay. Now, let us open the key. Fine. So, before opening the key, let me allow to erase out all these things so that I can explain you the second scenario. For the same diagrams, this second scene, simple one. There are two coils P and S. Now, K is open. Fine. In primary, sorry, in primary. So, what will happen? Now, in this diagram, the current will start reducing. So, this time the EMF will also start reducing. So, the induced current associated with the EMF, it will try to oppose that change. Fine. So, ultimately because of this flux change, once again the secondary coil will start feeling something opposite to the previous experience. Fine. So, these two situations, connecting the key opening the key. Something is happening while connecting the key, a reverse of this is happening in opening the key. Fine. So, again flux change in P, and due to this deflection in G, galvanometer, yes, in galvanometer. Ultimately, we are closing or opening. So, phi is directly proportional to I, at least for the primary coil we can say. Okay. So, from here now I will introduce a new term, that is not L but M. Reason is simple. Earlier there was only one coil, primary coil, and we were discussing phenomena associated with the primary coil. Now, primary coil phenomena, we know that self inductance is there, it is taking place, we know that entire story. A new character comes in the picture. So, we want to know something about this new character. So, this is M. Now, where M is a constant, defined as mutual inductance. Okay. Now, approach is similar, that is this induced EMF is equal to d phi by dt, but phi is equal to mi. So, as we did in the self inductance, so we will write it down as m d phi by m di by dt, di by dt. Okay. So, from here I can say m is equal to induced EMF, then di by dt. So, what I can say? I can say very simply that dimensional formula of M, units of M are same as that of L. So, it is an added advantage. You just learn about one quantity and you can expand your ideas about this second quantity also. And once again, if the minus sign is here like this, I am not writing because I know now you have the idea of this minus sign. Simply you can say opposing in nature, Lenz's law. Fine. So, just for your revision, minus sign, I will say simply Lenz's law. Fine. So, now here it is a basic introduction of mutual inductance. Now, you can say if the concept of self inductance is clear in your mind, then discussing the idea of mutual inductance is not anyway very difficult. Yes, for your this remembrance, I would like to mention, kindly please know how to find, I elaborated how to find the dimensional formula of L, same approach. Kindly know how to find dimensions, very important, dimensions and units of L and M. Okay. So, now once again I would like to request, now it's all is a part of your video. So, allow me to erase it out so that we can further expand our concepts. I think I will not erase out this diagram for the entire lecture, because if at any point of time it is required, I will take the help of this diagram where I created a primary coil and I created a secondary coil. Fine, basic diagram, nothing so specific about it. Now, I would like to mention one important aspect over here, that is factors affecting M, that is mutual inductance. Okay. Factors affecting M. What are those factors? They affect the value of M. Fine. So, those factors are number 1, shape and size of both coils. So, this is the first parameter, that is shape and size of both coils. In this, number of turns also important. Fine. Basically, on the concept of mutual inductance, your very important device transformer works, and it is something that you will learn in next chapter. Without transformer, this entire electricity with the help of which I am completing this video, you are charging your mobile phone, nothing is possible, because in homes the supply is AC, alternating current, and it is directly coming out. Fine. And I will discuss in next lecture or in coming lectures like AC generator, dynamo, DC or like that. So, this entire electricity, these so many sophisticated lights present in this studio, they are just glowing just because of this phenomena of transformer, and transformer device that works on the principle of mutual inductance. So, first is shape and size of both coils. If you have studied anything, if you know anything about transformer, then I am sure you know number of turns in primary, number of turns in secondary, and so on so forth. Fine. Number 2 is separation between two coils. Fine. So, if they are far away situated, then the coupling is not going to be very effective. Fine. I will discuss a coupling coefficient very soon. So, this is second point, separation between two coils, that is utmost important. Fine. Now, at some point of time, a confusing question may comes in your mind, how this parameter is important, that these two separated coils, what exactly the ideal distance. So, it depends upon the requirement of the circuit. Fine. Then third point in the same consequence, that is permeability of the core material in the coils. Fine. Permeability of the core material in the coils, that is third point. Fourth point is orientation of both coils with each. Fine. Means how they are oriented with each other, that is important. It is like that they may be in this manner, in this manner, in this manner, anything like that. So, how they are oriented, that will define how effective coupling between them is taking place. Okay. So, that is one aspect. Now, repeatedly I am telling you coupling fine of these two coils. So, I would like to mention directly the formula. Fifth point, that is coefficient of coupling of both coils is K is equal to M L1 L2 under root, and then put this entire relation fine. K is the coefficient of coupling of these two primary secondary coils is M upon L1 L2. L1 L2 is what? L1 L2 is self inductance of each coil. This primary coil has self inductance L1, secondary coil has inductance L2. So, this is something which is defined as the coefficient of coupling, fine. This derivation is something that is not as per this particular CBSE syllabus. So, that is why I am skipping that, I am directly mentioning this formula. Now, before moving ahead, obviously I will have to clean this board. So, over here just few moments I will take from your precious time just to make this board green and clean, and this diagram is still I do not want to erase, because at some point of time it may possible I may have to use to tell you something from this particular diagram. Now, there are certain direct results which may be important for some numericals. So, I think I should first discuss those results also. The value of M for two long solenoids, the value of M, that is mutual inductance for two long solenoids, it is actually if two long solenoids are placed together. Solenoid is something which I already discussed with you. So, it is like M12, that is mutual inductance of 1 with respect to 2. It is given by mu naught N1 N2 AL, where N1 is number of turns in coil number 1, N2 number of turns in coil number 2, A is area, L is length. Similarly, I should use a different color, M to 1 mu naught, you can write it like N2 N1 AL. There is no point of putting the terms together. 3 into 2 is equal to 6 and 2 into 3 is equal to 6. So, for simplicity and similarity, let me allow to write down like this. So, what you can say? You can say that M effective is equal to nothing but mu naught N1 N2 AL, fine. So, this is for two long solenoids, okay. Then comes the value of the value in the sense its expression. So, for given numbers you can find the value, that is why I am saying value, otherwise you can write it like also the expression for that, but I think it is a simple term. The value of M, that is mutual inductance for M for two concentric coils. Okay, two coils are concentric. Let us say one coil has radius r1, above that bigger one r2, axes are same for both, fine. So, it is going to be like M is equal to mu naught by 2. In some questions directly they may ask, that is why I am mentioning this, mu naught by 2 into pi r1 square upon r2. Okay. So, this is the basic idea of what? That is the basic idea of self inductance, which was in one previous video, then it is mutual inductance, which I tried to explain over here. One more important aspect left over here to explain, that is, actually this is a general rule, and I was about to explain it in some previous videos, a very simple concept, but I thought I missed it. So, just for a few seconds, that is, one is Fleming's, I am sure you all are aware with this rule, Fleming's right hand rule, not RHS, right hand side, right hand rule. This is my right hand in which I am wearing this simple ring. So, thumb, first finger, second finger. I am trying to draw it over here. Thumb, first finger, and then this one is the second finger. So, the thumb is representing motion of the conductor, motion, one term that you should remember. This first finger is B, in the direction of B, and then this second finger, they all are perpendicular to each other, I induced, fine. So, you can say like this, motion of the conductor, direction of the magnetic field, and it is what? Induced current, conventional direction of the current. So, this I think I not mentioned anywhere, so I think it is better to mention it, otherwise you all are aware with this result. So, anyway it is not a very difficult aspect, but do not revise this, try to apply this right hand Fleming's rule by this. Normally in my class I noticed students saying right hand rule, this is left hand, fine. So, right hand rule, and remember just one, either right hand or left hand, you are going to be in much better comfortable position. So, students, it was the basic discussion about mutual inductance, fine, in which I tried to explain you the basic idea as per the requirement of CBSE curriculum, where you can write down long answers. Please try to practice these diagrams properly, that will fetch you more good marks. So, once again with the same old suggestion, keep revising, keep working hard. Very soon I will come back with a new video to request the same thing again and again. Take care of yourself. Thanks a lot for watching the video.